नमस्कार दोस्तों, मैं शिवानंद उपाध्याय आपका स्वागत करता हूं हमारे YouTube चैनल केमिस्ट्री एकेडमी फॉर IIT जेईई एंड नीट। यह जेईई मेंस रिवीजन का दूसरा दिन है और आज हम सेकंड टॉपिक रेडॉक्स के बारे में डिस्कस करेंगे। और इस बात का ध्यान रखा गया है कि जेईई मेंस के हिसाब से मैं एनसीईआरटी से टॉपिक्स को डिस्कस करूं। देयर आर मेनी इंपॉर्टेंट टॉपिक्स बट वी आर टचिंग ओनली दोज विच आर इंपॉर्टेंट फॉर जेईई मेंस. So friends, we are starting with difference between oxidation number and oxidation state. So when we are discussing about oxidation number and oxidation state, let us take an example of ammonium nitrate. So it is an ionic compound. The cation is NH4 plus ion and the anion is nitrate ion. In NH4 plus ion, nitrogen is present in -3 oxidation state. When we are calculating oxidation state, what we'll do that we are assuming that when we are breaking a covalent bond, either it will break heterolytically or it will break homolytically. And if there is electronegativity difference, then we'll break it heterolytically and the shared electrons will go to the more electronegative atom. So here if you see, on breaking this covalent coordinate bond, the 2 electrons is of nitrogen. So on breaking it will remain with nitrogen. So there is no loss of electron by nitrogen atom. And here nitrogen and hydrogen is less electronegative. So all the shared electrons is taken by nitrogen. So nitrogen is taking 3 extra electron. Its oxidation number is -3. Same way, this is the structure of nitrate ion. In this structure, nitrogen is bonded with 3 oxygen atoms and oxygen is more electronegative than nitrogen. So on breaking of this covalent coordinate bond, the 2 electrons is shared by the nitrogen atom, but all these 2 electrons is taken by this oxygen atom. Because of that, there is 2 positive charge developed. So the total charge developed on this nitrogen atom will be 5. So I have told you how to break a covalent coordinate bond. If the covalent coordinate bond is moving from more electronegative to less electronegative, on breaking of bond, there is no development of charge. But if it is moving from, it is directed from less electronegative to more electronegative, on breaking the bond, the less electronegative has 2 positive charge and more electronegative has 2 negative charge. So nitrogen here is in -3 in ammonium ion and nitrate ion, it is in +5. These are the oxidation state. But when we are talking about oxidation number is average of oxidation state. So if we calculate the average of oxidation state in ammonium nitrate, there are 2 nitrogen atom. One nitrogen atom is present in +5, the other nitrogen atom is present in -3, and divided by number of atoms of nitrogen. So the average oxidation number is +1. So +1 is the average oxidation number. But be careful in JEE Advanced, in JEE Mains, because it is written in NCERT that oftenly we are changing the name. In place of oxidation state, we are using oxidation number. In place of oxidation number, we are using oxidation state. So unless and until they are asking that what is the difference, we'll assume that we'll consider that oxidation number and oxidation state will be same. Okay, then moving forward, let us discuss some examples given in NCERT. This is carbon suboxide, and if we draw the structure of this carbon suboxide, 3 carbon atoms and 2 oxygen atoms at the end. So carbon, all the carbon atom are sp hybridized. So if I break the bond between carbon atom, there is no development of charge, and oxygen is more electronegative than carbon. So this terminal carbon atoms are in +2 oxidation state, and this middle carbon is in 0 oxidation state. So there are 3 carbon atoms, but there are 2 types of carbon atom, one in +2 and one in 0. So they can ask a question that what is difference in oxidation number of 2 type of carbon atoms? So the difference is always positive. So it will be 2 - 0, that is equal to 2. Similar, another example is given in NCERT, Br308. The structure is also given here. So this is the structure, symmetric structure of Br308. So if I break this bond, because both bromine, all the bromine atoms are sp3 hybridized. So on breaking this bond, there is no development of charge. And oxygen is more electronegative than bromine. So on breaking this 4 bonds, there is +4 charge on middle bromine atom, and the terminal bromine atoms are in +6 oxidation state. So again, there are 3 bromine atoms, but 2 type of bromine atoms. The difference in oxidation number of 2 type of bromine atoms will be 2. It is mentioned that Br308 is paramagnetic, and I am giving you a trick which is not valid everywhere, but it is valid for a particular example. Whenever we are calculating the total number of electrons, and if the total number of electrons are odd, if there is odd number of electrons in a chemical species, then we can definitely say that the chemical species will be paramagnetic. So here we know that fluorine, chlorine, bromine, iodine and nitrogen has odd number of electrons. So if I count here Br308, since bromine atomic number is odd, if I multiply by 3, it is odd plus even is odd. So odd number of electrons, so it will be paramagnetic. Same way we can say for NO2, nitrogen has odd number of electrons, odd plus even is odd, again it is paramagnetic. So for diatomic ions and molecules, we'll apply molecular orbital theory to find out that those molecules are diamagnetic or paramagnetic. But for other chemical species, if we have to find out it is paramagnetic, this is a way to say that a chemical species is paramagnetic. So these examples are given in NCERT. If you go behind questions in the text of NCERT about peroxosulfuric acid, so it has similar structure as that of sulfuric acid. Only difference is in sulfuric acid we write sulfur double bond oxygen, OH and OH. On one side it is peroxide bond. So here 2 oxygen atom is present in -1 oxidation state, and this sulfur is present in +6 oxidation state. Some of the student who do not draw the structure or don't follow the range of oxidation state can do error, because generally in their compounds hydrogen is present in +1 oxidation state and oxygen is present in -2 oxidation state. From there, if I calculate that what is the oxidation number of sulfur, so from that formula if I use, the sulfur is present in +8 oxidation state, which is wrong, because oxidation number range can be decided by this formula, Roman group number -8 to Roman group number. So like for oxygen family, the Roman group number is for oxygen family is 6. So 6 minus 8 will be -2 to Roman group number, that is 6. So in oxygen family, the variation of oxidation number is from -2 to +6. I'm not saying that oxygen will show +6 oxidation state. We are talking about family. Like sulfur can show +6 oxidation state in H2SO4, and in H2S sulfur is in -2 oxidation state. Same way for halogen family, the variation will be -1 to +7, and the highest oxidation number of chromium, because Roman group number of chromium is 6, right, and manganese is 7. From there we are saying that in K2Cr2O7 and in KMnO4, chromium is in +6 oxidation state and manganese is in +7 oxidation state. In iron family, the elements of iron family is iron, ruthenium and osmium, and it is in Roman group number 8. So osmium is in +8 oxidation state in compound OSO4. So this is the highest oxidation state of any element in periodic table, that is osmium. It exists in +8 oxidation state. Apart from that, xenon also can exist in +8 oxidation state in this ion, XeO6 4- ion. We'll discuss the structure of this. This is the structure of XeO6 4- ion, where xenon is present in +8 oxidation state. If you break all the bond, xenon is present in +8 oxidation state, and it's a very good oxidizing agent. It can oxidize F- ion to fluorine. It is the only compound which can oxidize F- ion. Otherwise, F- ion cannot be oxidized. So sodium tetrathionate, this is very important chemical species, because in iodometry, whenever we have to find out what is the amount of iodine liberated, we react iodine with hypo solution, Na2S2O3 solution, and iodine is converted into NaI, and Na2S2O3 hypo solution, sodium thiosulfate is converted into sodium tetrathionate. So in sodium tetrathionate, it is an anion of thionic acid, tetrathionic acid. This is the structure of tetrathionic acid. So there are 4 sulfur atom in it, and if you find out that what is the charge developed on breaking this bond, because all the sulfur atom is sp3 hybridized, on breaking this bond between sulfur atom there is no development of charge. So these 2 sulfur atoms is in 0 oxidation state, and here if you break sulfur will lose 5 electrons. So sulfur is present in +5 and +5 oxidation state. So there are two type of sulfur atom. The terminal sulfur atoms are in +5 oxidation state, and the middle sulfur atoms are present in 0 oxidation state. Already this question has been asked in JEE Advanced, that what is the difference in oxidation number. So in place of saying oxidation state, they have used the word oxidation number of two type of sulfur atom in tetrathionate ion, and the answer is 5. So for sodium thiosulfate ion and sulfate ion are similar, because when we are discussing about sulfate ion, this is the structure of sulfate ion: S double bond O, O minus and O minus. In place of oxygen, if we replace this oxygen by sulfur, then this is thiosulfate ion. So here in thiosulfate ion, this sulfur atom is sp3 hybridized. The central sulfur atom is sp3 and the terminal is sp2 hybridized, and there are certain experimental results which are telling that this sulfur, we are getting sulfide ion, and we are getting sulfide ion. That's why we are applying this theory that this sulfur is in sp3 hybridization, central sulfur atom, and terminal is in sp2, and we know that S character is more in sp2. So we are considering that this terminal sulfur atom is more electronegative than this central sulfur atom, and that's why when we are breaking this bond, the shared electron is taken by this terminal sulfur atom. So this sulfur atom is in -2 oxidation state, and this sulfur atom is in +6 oxidation state, right? And this concept cannot applied everywhere. There is experimental proof. That's why while breaking the bond, we are getting sulfide ion, right? So we have to justify that how this sulfur is in -2 oxidation state. So this is also a very common question, that there are two type of sulfur atom in sodium thiosulfate. What are their oxidation states? So one is in -2 and other is in +6. If we find out average, then +6 minus 2 is +4, +4 divided by 2 is +2. So sulfur oxidation number is +2. And we have already discussed about this perxenate ion, where xenon is present in +8 oxidation state. This perxenate ion is given in NCERT in backtest questions. They have given a reaction of perxenate ion with F-. So this is within NCERT. Now I will discuss balancing of redox reaction. In balancing of redox reaction, there are 3 steps involved. The first step is balance those atoms whose oxidation number is changing, then balance the charge, and then balance those atoms whose oxidation number is not changing, right? And I have taken this example. I have gone through past year papers so many times. They are asking reaction between KMnO4 and more salt, and more salt is FeSO4 dot NH4 whole twice SO4 dot 6 H2O. We are using in lab. More salt is used as a primary standard for standardization of KMnO4, because KMnO4 is very sensitive to light. It is very reactive. So before doing titration of KMnO4 with other chemical species, we find exact composition or exact concentration of KMnO4. For that, we titrate KMnO4 with more salt. More salt is primary standard, right? So when we are using more salt, in more salt only iron +2 is the reducing agent. Iron +2 is going to convert into iron +3. In acidic medium, we should know that KMnO4 is an oxidizing agent, then it will convert into Mn2+ ion. Even any higher oxidation state of manganese in acidic medium will convert into Mn2+. If MnO2 is there, it will convert into Mn2+. So here the reaction is given, and we are trying to balance this reaction in 3 steps. One way is we can separate the reaction and balance, like oxidation reaction. I have written here that iron +2 is converted into iron +3 with loss of 1 electron. So this is the balance reaction, because we have balanced those atoms whose oxidation number is changing. We have balanced the charge, and there is no other atom whose oxidation number is not changing. So oxidation part is balanced. Now reduction part we have balanced separately. MnO4 minus manganese is in +7 oxidation state. It will take 5 electron to form manganese +2. So manganese on the left hand side and right hand side is 1. Then we have to balance the charge. On the left hand side there is 6 negative, on the right hand side 2 positive. So that's why we have added 8 H+ ions. And then we have to charge is balanced. Then third step, balance those atoms whose oxidation number is not changing, that is hydrogen and oxygen. On the left hand side hydrogen is 8. So in order to balance 4 times of H2 on right hand side. So this is the balance reaction. Now we add up these two oxidation and reduction reaction, and in redox reaction, one chemical species giving electron, other is taking. That's why we are multiplying the first oxidation reaction by 5. So in order to make the number of electrons equal, or we can balance this reaction here by this method. What we'll do, that we'll find the X factor. So fluorine is present in +2 and going to +3. There is loss of 1 electron, so X factor is 1. X factor is number of electrons lost or gained by a chemical species. For MnO4 minus is present in +7 going to +2. So it is taking 5 electrons. So this chemical species is taking 5 electrons. So X factor will be 5. When we are multiplying, cross multiplying, basically we are making the number of electrons equal. If I multiply here by 5, right? So what I am saying, that 5 ions of iron +2 will take 5 electrons to form 5 ions of iron +3. Because MnO4 minus will take 5 electrons, right? So iron +2 will give 1 iron +2 will give 1 electron. So 5 iron +2 will give 5 electrons to form 5 Fe3 plus ion. So we are making the number of electrons equal. So first we'll calculate the X factor, we'll find out the simple integral ratio, and then we'll cross multiply to make the number of electrons equal. Now we are balancing those atoms whose oxidation number is changing. So we have cross multiplied. Now we are balancing iron here 5, iron here 5, manganese 5, manganese. So first step is completed. Now in acidic medium, we have to balance the charge. So on the right hand side, if you see, the charge is 15 plus 2, 17. 17 positive charge is there on the right hand side. On the left hand side, if we count the number of charge here, this is 10, 10 and -1 will be 9. So we have to balance the charge. In order to balance the charge, we have to add 8H plus ion on the left hand side. On adding 8 plus 9 will be 17. 17 and 17 will be equal. So we have balanced the charge. Then we have to balance those atoms whose oxidation number is not changing, that is hydrogen and oxygen. On the left hand side, hydrogen is 8. So on the right hand side, we can add 4 times of water molecule. So this is the balance reaction. 3 steps are there. First, we balance those atoms whose oxidation number is changing. Then we'll balance the charge. And then we'll balance those atoms whose oxidation number is not changing. Let us take another example. Again, this titration between K2Cr2O7 and more salt in acidic medium. This titration we are doing in lab. And so many times they are asking in JEE mains. So balancing of this reaction, again, K2Cr2O7 is an oxidizing agent in acidic medium only. This reaction is taking place in acidic medium because K2Cr2O7 is unstable in basic medium. It will convert into K2Cr4. So when we are discussing this reaction, let us use that method which we have used in the past reaction. So first we'll calculate what is the X factor. Chromium here in +6 oxidation state, chromium +6 oxidation is going to +3 oxidation state. There are 2 chromium atom. One chromium atom is taking 3 electrons. So total electron taken by this iron is 6. So X factor of this is 6. Iron is losing 1 electron. So iron +2 to iron +3. So here X factor will be 1. So now I am cross multiplying in order to balance the number of electrons. So here 1 electron, here 6 electrons. So I will multiply this by 6. And now we are going to balance those atoms whose oxidation number is changing. So here chromium are 2. In order to balance chromium, right hand side 2, iron, right hand side 6. First step is completed. We have balanced those atoms whose oxidation number is changing. Now we have to balance the charge. Medium is acidic. On the left hand side, 12 and -2, +10 charge is there. On the right hand side, if we count 18 plus 6, 24 is there. So in order to balance the charge, positive charge, we have to add 14H plus on the left hand side. And then the charge is balanced. In order to balance those atoms whose oxidation number is not changing, we have to balance here by adding water molecules, 7 times of water molecule, because we need 14 hydrogen atom and 7 oxygen atom. So this is the balance reaction. So this is the way to balance a chemical reaction. 3 steps are there. Now there are certain reactions of KMnO4 in acidic medium. These reactions are given in, few of them are given in redox, and few of these reactions are given in D block reactions of KMnO4. So this is all reaction is from NCERT. The first reaction already we have discussed. We are using this reaction in lab. We are doing titration of KMnO4 with oxalic acid or salt of oxalic acid. So where oxalate ion is converted into carbon dioxide. So you should know that what is the product form when KMnO4 is going to react with oxalate ion or oxalic acid. Oxalate ion or oxalic acid is converted into CO2 in acidic medium. This reaction already we have discussed. This is about more salt. Similarly, if nitrite ion is there, it is converted into nitrate ion. Iodide ion is there, it is converted into iodine. This is important because corresponding to this, there is a reaction in neutral or weakly basic medium. We'll compare it later. H2S is converted into sulfur and sulfite ion is converted into sulfate ion. So you should know the product of these reactions. Now, we know that KMnO4, they're asking X factor of KMnO4, right? In many coachings, we are teaching that KMnO4 in acidic medium is converted into Mn2 plus ion. Then KMnO4 in weakly basic or neutral medium, it is converted into MnO2, where the X factor will be 3. It is taking 3 electrons. And very basic medium, it is converted into K2MnO4. So from +7, it is going to +6, X factor will be 1. But we never use highly basic medium for any titration, right? It is expensive, it is of less use, right? So whenever if it is not mentioned that it is weakly basic or highly basic, our first instinct is we will take weakly basic. And in weakly basic medium, KMnO4 is converted into MnO2. It is taking 3 electrons, so X factor will be 3. Now, MnO4 minus in weakly basic medium has a X factor of 3, and it is a very good oxidizing agent. So you should distinguish here. You should not confuse with this. I minus to I2, it is in acidic medium. But the same I minus in weakly basic medium is converted into IO3 minus. So this is important. Many times in JEE Advanced, they have asked this reaction. So I minus in weakly basic is converted into IO3 minus, while in acidic medium, I minus is converted into I2. Similarly, in weakly basic medium, this KMnO4 is converted into MnO2. So thiosulfate ion, because why we are discussing, why we confuse that thiosulfate ion, we have studied so many times that whenever iodine is liberated, thiosulfate ion is converted into S4O6 2 minus ion, tetrathionate ion. And there we have calculated so many times that the X factor of thiosulfate ion is equal to 1. But here it is not reacting with iodine. It is reacting with KMnO4. And KMnO4 will oxidize in neutral medium or weakly basic medium. It is converted into sulfate ion. So be careful. In JEE Advanced, this question was there. So here the sulfur oxidation state, if you calculate the oxidation state of sulfur in thiosulfate ion, sulfur is present in +2 oxidation state. In sulfate ion, sulfur is present in +6 oxidation state. So if I calculate what is the X factor of thiosulfate ion, there are 2 sulfur atoms. Sulfur is moving from +2 to +6. So 4 electrons is lost by 1 sulfur atom. So the X factor of this is equal to 8. So already in JEE Advanced, they have asked this question about thiosulfate ion reaction to form sulfate ion. This is given in your redox chapter in NCERT. Be careful about this. So these reactions are important. Now this third reaction is Mn2 plus and MnO4 minus will combine to form MnO2. This is comproportionation reaction. Manganese here in +2, manganese here in +4, manganese, here manganese is in +7 oxidation state going to +4 oxidation state. Comproportionation reaction is reverse of disproportionation reaction. In disproportionation reaction, same element is at least in 3 different oxidation state. So it's a comproportionation reaction. These reactions are given in D block and they have asked so many times in JEE Advanced. So they are very important reaction to us. Again, I am repeating. I minus in acidic medium is converted into I2, but I minus in weakly basic medium is converted into IO3 minus. And KMnO4 in weakly basic medium can oxidize thiosulfate to sulfate ion. Iodine will oxidize thiosulfate to tetrathionate ion, where the oxidation number will change from +2 oxidation state to 2.5 oxidation state. We are going to discuss that part also in iodometry. Right. So now there are certain problems in NCERT it is mentioned, and since the question is asked in JEE Advanced, that's why I'm discussing this point. In the problem, if it is mentioned that KMnO4 oxidize I- to I2 in weakly basic medium, then you don't confuse with IO3-, because if you go through your redox chapter in text questions, this reaction is given. They are saying in the question that I- is converted into I2 in weakly basic medium. Balance the reaction. So if in the question, if they are saying that I- is converted into I2, they are not asking that what will happen to I- in weakly basic. If they are asking, then you will say that the product will be IO3-. If they are saying that this is the product, please balance the reaction. So don't confuse. In JEE Advanced, this question came, which is given in NCERT. And in question, they are saying that I- is converted into I2. So why you are confusing? They are not asking that what is the product. If they are asking what is the product, definitely in past JEE questions, they have asked this. And we have written that I- is converted into IO3- in weakly basic medium. But if they are saying the product is I2, just balance the reaction. Then you have to focus on just balancing the reaction. Don't confuse with the product. Many of the students get confused because they know both, that in weakly basic it is converted into IO3-, and this question is given in your NCERT, where you are while balancing, they are saying that product is I2, balance the reaction. So don't confuse it. Reaction of K2Cr2O7 in acidic medium. Again, I am saying that this we are using in lab, this more salt reaction with K2Cr2O7. So iron +2 is converted into iron +3. This also we are using in lab. Oxalate ion is converted into carbon dioxide. Apart from that, I- is converted into I2, and H2S is converted into sulfur. Tin +2 is converted into tin +4. So there is nothing confusion of reaction of K2Cr2O7, and K2Cr2O7 is oxidizing agent only in acidic medium. In basic medium it cannot exist. It is converted into K2Cr O4. Okay, so this is a question given in NCERT, and they can ask from, because it is given and it is a very good reaction used in metallurgy, that is known as self-reduction method, right? So this reaction is given. They are saying balance the following reaction and find the equivalent weight of oxidizing agent and reducing agent. So here cuprous oxide, copper is in +1, oxygen is -2. Then here copper is present in +1, sulfur is present in -2. On the product, copper is in 0 oxidation state, sulfur dioxide, sulfur is present in +4, oxygen is in -2. So oxygen is not changing its oxidation number in all the compound. Wherever it is in -2. It is not participating in redox, right? Then copper from +1 is going to 0, and sulfur from -2 is going to +4. So if I calculate the X factor of Cu2O, so in Cu2O, because it is oxidizing agent, because Cu2O, copper +1 is going to 0, it is taking 2 electrons. In case of Cu2S, copper is taking electrons, but sulfur is losing electron. One atom of sulfur is losing 6 electron, -2 to +4, loss of 6 electron. And 2 atoms of copper is taking 2 electrons. So overall, Cu2S, one particle, is losing 4 electrons. So we can say Cu2S here is acting like a reducing agent, or specifically we can say that sulfur in Cu2S is acting like a reducing agent. So if we balance this reaction, X factor of this is 2 and X factor of this is 4. We'll take simplest integral ratio, so 1:2, and then we'll multiply. In order to, why we are multiplying? To make the number of electrons equal. So if I multiply here by 2, now we'll balance those atoms whose oxidation number is changing. So copper 4 + 2, 6. So here 6. Sulfur already balanced. So copper and sulfur is balanced. Now we have to see about oxygen. Oxygen here 2, left hand side, right hand side 2. So this reaction is balanced. Now if they are asking what is the equivalent weight of this oxidizing agent, we'll say that that is equal to molar mass divided by X factor. X factor is 2. If they are saying that what is the equivalent weight of Cu2S, which is acting like an reducing agent, that is equal to molar mass divided by X factor is 4. So this is the equivalent weight of oxidizing and reducing agent. In NCERT, when they are discussing, they have mentioned that sulfur in Cu2S is the reducing agent. whole molecule is losing 4 electrons, especially sulfur is losing electrons. That's why they're saying that sulfur in Cu2s is the reducing agent. This is also a very important reaction, very common in exams. So they are asking that why do the following reactions proceed differently? The reaction is Pb3O4 and HCl and Pb3O4 and HNO3, right? So Pb3O is common and it is reacting with two acids and the reactions are different. So we have to explain that why the reactions are different. So first thing is that Pb3O4 is not a compound. It is a mixture of two compounds, PbO and PbO2. And it is in molar ratio 2:1, because if you write two molecules of PbO and one molecule of PbO2, then number of lead atoms will be 3, number of oxygen atoms will be 4. So Pb3O4 is a mixture of PbO and PbO2 in 2:1 molar ratio. Now PbO2, since lead is present in +4 oxidation state, it is a very good oxidizing agent. So in the first reaction we are discussing that this PbO2 is a very good oxidizing agent. It can oxidize HCl to Cl2, and between PbO and HCl there is acid base reaction. It is a non-redox reaction. So let us divide this whole reaction in two parts. PbO and HCl is reacting like acid and base, because this is basic oxide and this is acid base reaction. So there is formation of salt and water. We have balanced this reaction. The second reaction is redox reaction. PbO2 is an oxidizing agent, so it lead in +4 will go in lead in +2. So there is formation of PbCl2 where lead in +4 is going to +2, so X factor is 2. HCl, chlorine in -1 is going to 0, X factor is 1. So if we cross multiply, here we are multiplying by 2 in order to balance the number of electrons. Then we count the atoms whose oxidation number is changing on left and right. On the left, lead is 1. On the right, lead is 1. Chlorine on the right, whose oxidation number is changing, is 2. On the left, whose oxidation number is changing, is 2. Now there are two types of chlorine on the right hand side, one whose oxidation number is changing and one whose oxidation number is not changing. So third step, now we have to, there is no charge balancing, so we are moving from first step to directly third step. So lead here, sorry, chlorine here is in -1. There are two atoms of chlorine. They are not participating in a redox reaction. So we have to balance those. So in order to balance that, we have add 2 molecules of HCl. So on the left hand side, 4 molecules of HCl. And now hydrogen atom on left hand side is 4. So in order to balance, we are multiplying by 2 moles of water. And now we count the oxygen atom, it is balanced. So there is a fixed question, though this question will not come in JEE mains, but coaching people will ask a fixed question that what is the equivalent weight of HCl? So there are, when we are discussing about this HCl, there are 4 molecules of HCl. 4 molecules are there. And when we are balancing this reaction, how many electrons are participating in this? 2 electrons are participating in this. So 2 electrons are participating for 4 molecules. If I calculate what is the equivalent weight, so I have to calculate X factor. X factor means for one molecule, how many electrons are participating. For 4 molecules, 2 electrons are participating, means for one molecule, half electrons will participate. So equivalent weight of HCl in this reaction is equal to 2 times of molar mass. If they are asking what is the equivalent weight of HCl participating in oxidation, then HCl is moving to Cl2, X factor is 1. Then we can say X factor, so equivalent weight of that part of HCl is equal to molar mass divided by 1. But for the whole HCl, there are 2 parts. So equivalent weight here is equal to 2 times of molecular weight. So this is also a very common question. So I have discussed that in the first part of the reaction, PbO2 is acting like an oxidizing agent and PbO is reacting with HCl as base. So there is acid base reaction which is non-redox, and there is a redox reaction. While in case of the second one, when Pb3O4 is reacting with HNO3, let us move to the other page. So the second case, Pb3O4 is reacting with HNO3. Here HNO3 is an oxidizing agent and PbO2 is also an oxidizing agent. So PbO2 is not going to react with HNO3. So here only PbO is going to react with HNO3 and it is an acid-base reaction. So in this acid-base reaction, there is formation of salt and water. We can balance this reaction, salt and water, and PbO2 is not participating in the reaction. So it is present initially and finally also. So if we add these two, we'll get that Pb3O4 plus 4HNO3 molecule will form 2 times of lead nitrate plus PbO2 plus 2 times of H2O. So this reaction is non-redox reaction, while the first reaction has two part, redox as well as non-redox. So this is a very common question in exam. Now already I have made a video of disproportionation reaction. So those people who have problem in balancing a disproportionation reaction, a full video of disproportionation reaction where the examples is also discussed from NCERT. I have written those examples, and I want to say there also I am saying that you should know the product formed during a disproportionation reaction, which is given in NCERT. Like you know that H2O2 will convert into H2 and O2. This is very common reaction, right? Similarly, in basic medium, this is also very important reaction. Chlorine will disproportionate to form chloride ion and hypochlorite ion. Chloride ion and hypochlorite ion. Hypochlorite, HOCl. Hypochlorous acid. Us acid to ITE, ITE, hypochlorite ion. Same way we can say for Br2, I2. But this is important. Again, it is mentioned in NCERT. Fluorine is a very good oxidizing agent. So when fluorine is added to water or basic medium, it will oxidize water. So in water, oxygen is -2. When water will oxidize, oxygen will be in +2 oxidation state. So here oxidation of water will take place. So this reaction is given in NCERT, and they can ask this reaction. Fluorine is not participating in disproportionation. This is not a disproportionation reaction. So there is reduction of fluorine to F minus, and there is oxidation of oxide ion to this, in which oxygen is present in +2. So oxygen from -2 is going to +2 oxidation state. Let us take some other examples given in NCERT. So you should know the product. So many times in JEE Advanced Mains, they have asked this question, disproportionation of white phosphorus. So phosphine gas, where phosphorus is present in -3 oxidation state, and this is hypophosphorus acid. So hypophosphite ion. So here the phosphorus is present in +1 oxidation state. So many times in JEE Mains and Advanced, they have asked that what is the oxidation state of phosphorus undergoing oxidation. So that is +1, undergoing reduction, that is -3. Same way, sulfur on disproportionation will convert into sulfide ion and thiosulfate ion. Sulfide ion and thiosulfate ion. So in sulfide ion, sulfur is in -2. Thiosulfate, sulfur is in +2 oxidation state. This is given in back questions of NCERT. Cyanogen gas in basic medium is converted into cyanide ion, and this is cyanate ion. Cyanate ion. So you can draw the structure, and from the structure you can find out that I have discussed this point in disproportionation. Please go through it. I think this is the structure O minus C triple bond N. So here nitrogen is present in -3 and carbon is present in +4 and oxygen is present in -2 oxidation state. And if we add all these three, overall oxidation number, oxidation charge on this will be -1. That is coming true, right? So here carbon is present in +4. Nitrogen is not changing its oxidation number. Carbon is going disproportionation. So carbon in Cn- we know, and in cyanogen gas also we know. From there we can find out. So already this thing is discussed in your disproportionation part. You can go through it, right? In the back question, there is a problem where they are asking that give some examples of non-metals undergoing disproportionation. Already we have discussed sulfur, phosphorus, halogens will undergo disproportionation in basic medium. They're also asking some metals which can undergo disproportionation, and the purpose of asking that, for disproportionation, the same element should present in at least 3 oxidation state. Means the metal should have variable oxidation state, like alkali metal, alkaline metal, aluminium, it cannot disproportionate. So who is going to disproportionate? Like copper. Copper in +1 oxidation state can disproportionate to copper and copper +2. Or thallium. Thallium in +1 oxidation state is converted into thallium and thallium +3. Or manganese. We have studied that manganese +3 in acidic medium in examples of disproportionation is converted into manganese 2+ and MnO2. So keep this in mind that many times in question they will ask that any higher oxidation state of manganese like MnO2 is there and medium is acidic, what is the product form? So in acidic medium, MnO2 will convert into Mn2 plus. So the final product will be Mn2 plus in acidic medium. There is another question regarding disproportionation. They are asking that which of the following chemical species will not disproportionate. Again, this question is based on range of oxidation number for a particular element. Like here they are talking about chlorine. For chlorine we know that the oxidation number vary from -1 to +7. So in ClO minus, chlorine is present in +1 oxidation state. Here it is present in +3 oxidation state. Here it is present in +5 oxidation state, and here it is present in +7 oxidation state. So +7 is the highest oxidation state. It cannot further oxidize, right? So that's why ClO4 minus do not undergo disproportionation, or we can say that Cl minus ion do not undergo disproportionation because it is the least. इसके बाद इसका further reduction नहीं हो सकता. Here they can oxidize as well as reduce. So these three chemical species will go disproportionation reaction, and these are few reactions which is given in NCERT. So I have written at a particular point and I want to discuss. In this reaction of thiosulfate ion with iodine, this is related to iodometry. So here sulfur is present. I am writing oxidation number in +2 oxidation state, and here there are 4 sulfur atom, 2 sulfur atom in +5, 2 sulfur atom in 0. So average value is 2.5. So if I calculate what is the X factor here, so X factor of this is, there are 2 sulfur atoms, so 2 times moving from 2 to 2.5, half. So X factor of thiosulfate ion in this reaction is equal to 1. The same reaction, these two are given in a same question. They are saying that now the thiosulfate ion when reacting with iodine, we have done so many times that it is converted into tetrathionate ion. But when thiosulfate ion is reacting with bromine, why it is converted into sulfate ion? Explain. So we should know that in case of halogen, chlorine, fluorine, bromine and iodine, if we discuss about that which is the best oxidizing agent, so we'll say that the order of oxidizing agent means these chemical species are going to reduce, they are converted into halide ion, then they are good oxidizing agent. So the oxidizing agent, least oxidizing agent is iodine, then bromine, then chlorine, and the best oxidizing agent is fluorine, because fluorine in its compound always want to exist in F-1 oxidation state. If the question is reverse, among the following which is the best reducing agent? For reducing agent, if I am discussing, then fluorine is the worst reducing agent, then chlorine, then bromide ion, and then iodide ion. Iodide ion is the best reducing agent in the halide ion, and in the halogens, fluorine is the best oxidizing agent. So the question is based on this. These data are given for oxidation potential of iodine, bromine, chlorine, fluorine, they have given there. So based on that data, they are asking that why these two reactions are different. So you have to remember this. Iodine you always know, but because of iodine you should not confuse. With bromine the reaction is different, it is converted into sulfate ion. So they can ask in JEE Advanced also that when thiosulfate ion is reacted with bromine, the product form, find out the oxidation state of sulfur atom in that product. So that is present in +6 oxidation state. There is another question, I have discussed this question in disproportionation reaction also, or balancing of redox reaction. They are asking that why it is better to write this oxygen and oxygen separately. So again here ozone is an oxidizing agent and H2O2 can act as both, but in this reaction H2O2 is an reducing agent. So when we are discussing about ozone is unstable, it will convert into O2 plus nascent oxygen, and this nascent oxygen will take electron to form oxide ion, and this oxide ion, if the medium is basic, this oxide ion will exist in the form of OH minus. If the medium is acidic, then this oxide ion will exist in the form of H2O. So the part of oxygen in ozone which is participating in redox, either it will convert into OH minus or it will convert into H2O. So here when we are discussing this H2O here, means the reaction is taking place in acidic medium, the ozone oxygen, nascent oxygen is taking 2 electrons and it is converted into H2O. So the X factor of this, because one oxygen molecule is, ozone molecule is taking 2 electrons, X factor is 2. When we are talking about H2O2, since H2O2 is acting like reducing agent, so H2O2 itself converted into oxygen. It is converted into oxygen. So X factor, oxygen from -1 is going to 0, X factor is 2. So one oxygen molecule is from H2O2 and one oxygen molecule is for ozone. This oxygen molecule which is coming from ozone is not participating in a redox reaction. It is just decomposition of ozone to oxygen and nascent oxygen. Nascent oxygen is participating in redox. So that's why 2 times it is right. It is better to write in this form in order to explain that oxygen is coming from ozone as well as H2O2. And this fourth reaction is giving, this is the only chemical species which can oxidize F- ion. And here xenon is present in +8 oxidation state going to +6. X factor of this is equal to 2. And fluorine is moving from -1 to 0. X factor of this is equal to 1. Now you can balance the reaction. So this reaction is also given in NCERT. These two reactions, because hypophosphorus acid is a very good reducing agent. In hypophosphorus acid, phosphorus is present in +1 oxidation state and phosphorus from +1 is moving to +5 oxidation state. So it can reduce Ag plus iron to silver and it can reduce copper 2 plus iron to copper. So these reactions are given in NCERT and these reactions are used in inorganic chemistry, right? When we discuss about oxy acids of phosphorus. So this is given in redox. This is important, right? You should know that hypophosphorus acid can convert AgNO3 to Ag and itself converted into phosphoric acid. If you know this product, you can balance the reaction. Now we are going to discuss the last point, iodometry. So whenever we are discussing, there is iodimetry and iodometry. Iodimetry means direct reaction with iodine. If we want to analyze something, we have to direct react with that chemical species with iodine, then it is iodimetry. But when we are discussing about iodometry, we want to know about some chemical species. The chemical species which we want to know is known as analyte. So analyte is there. We want to know about this chemical species, and in iodometry, this chemical species about which we want the information is oxidizing agent. This is an oxidizing agent. For example, here, this is very important in JEE Advanced. There are questions based on this. In mains also, this is important because this is a method where in a mineral we'll find the amount of copper 2 plus ion. So in a mineral, copper sulfate, copper 2 plus ion is there and we want to know about it. There is impurity inside it also. So what we'll do that? We'll titrate this copper sulfate with excess of Ki. So this is copper sulfate is analyte or copper 2 plus ion is analyte. We want to know about this. So we are treating with Ki, and the reaction is copper from +2 is going to copper +1. So copper +1 is in solid state, it is stable. In aqueous medium, it is not. So this solid will form Cu2I2 and iodine gas will be liberated. And this is the product. So this is the one reaction. The iodine liberated here is reacted with hypo solution, where iodine is converted into NaI and thiosulfate ion is converted into tetrathionate ion. So in this reaction, we want to know about copper sulfate. From this balance, if this we have balanced the reaction, from this reaction we can say that the number of moles of copper sulfate is equal to 2 times the number of moles of iodine, because 1 mole of iodine, 2 mole of copper sulfate. In the second reaction, we can say that number of moles of sodium thiosulfate or hypo solution, right? Na2S2O3, number of moles of Na2S2O3 is 2 times the number of moles of iodine. So by using that, we can say that number of moles of copper sulfate is equal to the number of moles of hypo. So when we do the titration, we know the information about hypo. They will give that what is the molarity and volume of hypo used. So by knowing the moles of hypo, we can find out what is the number of moles of copper sulfate. So we can find out what is the percentage of copper +2 ion or copper sulfate in the mineral, because there are certain impurity which are inert. So the analyte is oxidizing agent. Same way here, we want to know about this BrO3 minus ion, bromate ion. So we are reacting this with excess of I minus. So I minus is converted into iodine and BrO3 minus is converted into Br2. So here it is acting like an oxidizing agent. The iodine liberated again is treated with hypo solution, and further we know. So in this balance reaction, we can say that second balance reaction, we can say that number of hypo, moles of hypo is equal to 2 times the number of moles of iodine. And in the first reaction, I can say that number of moles of iodine. If this is 1 mole, this is 5/2. So 5/2 times the number of moles of BrO3 minus ion. So from here I can put the value that number of moles of hypo, if I put the value here, right? So number of moles of hypo divided by 2. In place of iodine, number of moles of hypo divided by 2, 2 and 2 in the denominator is cancelled out. So I can write that that is equal to 5 moles of BrO3 minus. So they will give about hypo, we can find out about BrO3 minus, right? So this is known as iodometry. We want to know about something is reacted with excess of Ki, iodine will liberate it, that iodine is treated with hypo solution. So I have tried my best to summarize about redox, and I have find that for JEE Advanced, redox is more important. In JEE Mains, less number of questions are asked from redox, more number of question is asked from mole concept. It's a easy topic. Mole concept is relatively a easy topic than redox. So I want to say that whatever videos we are making, the PDF of that we are attaching with that particular video also. You can go in comment and check that PDF. So you can download that also. Thank you.